Morning, everyone. Welcome to the second surgery session for United Utilities Water Industry Printfrastructure project. I'm Ellis. I'm a marketing and comms exec from Spring Innovation. For those of you who don't know Spring, we are the UK Water Sector Centre of Excellence, and we're supported by water companies, the supply chain, and academia. There's two main sides to our business: knowledge transfer and innovation. We exist to help speed up innovation in the sector, remove duplication, and facilitate knowledge transfer of projects so the whole sector can learn from a specific company's progress. More information about us can be found on our website and LinkedIn, which I'll add links into the session chat near the end. So on to today, why are we hosting this session? This session's been created with the aim of instigating a detailed discussion around the Printfrastructure project. I hope that by hosting this session, I'll not only be able to help the project team reflect and progress on aspects of the project, but also allow for knowledge sharing across the sector, and hopefully sort of create some future collaboration. Coming back to the Printfrastructure project, it's made up of two different 3D printing types, concrete and plastic, but today this session focuses specifically on the concrete printing elements. Today we'll hear from United Utilities' Richard Clark, alongside Natalie Wadley, co-founder and CEO of ChangeMaker3D, who are a key partner on this project. We'll aim to conclude this session probably around 11:30. That is, roughly where we'll be at. The session recording, slides and notes will all be available on the Spring platform in approximately a week's time. I'll email you all a link when this is ready. I'll reply to the meeting invite so you can see that. And later on in the presentation, we'll be moving over to the Miro board so we can all add our thoughts to it. I'll share a link to this in the meeting chat when Richard and Natalie are presenting. On to the agenda for today. So we'll start with Richard providing a brief overview of the entire project. We'll then move on to Natalie, who will provide insight into the 3D concrete printing and approaches behind the process. After that, as I say, it's over to you. So we'll be moving on to the Miro board, and we'll have 5 questions to discuss that are on there. Everyone can add post-it notes, contribute via the chat, sort of engage via your mics and stuff, ask any questions that you've got. And with that, if you're happy, Richard, I'll now hand over to you.
Yeah, absolutely brilliant. I just need to take control, don't I? There we go. I think I have it now. Yeah, thank you, Alice, for the introduction. And well, thank you to you all for joining us this morning. Richard Clark, I'm Programme Manager for Engineering Innovation at United Utilities. And well, I've been working alongside Natalie and the team at ChangeMaker3D now for a good 3 or 4 years, just looking at how we can potentially use 3D concrete printing within the water industry. We're an Ofwat-funded project, okay, so we 90% of the funding for our current scheme is provided through the Ofwat Innovation Programme. The other 10% is provided by our project partners, so UU, yes, but Scottish Water, Manchester Metropolitan University, and ChangeMaker3D. And some of you will have heard what I have to say a number of times before. It's just really important that we get you all on a level playing field before we enter into what is more of a discussion and an ideas session later on in this call. Why we did this? Why Ofwat liked this particular bid? Well, going back a few years, we'd worked with ChangeMaker through our innovation lab at United Utilities. We'd helped Natalie and the team get a good feel for what was required within the water industry. We'd printed the first water retaining tank at our Weaver and wastewater treatment works, and we had a good feel for what this meant to us, how we wanted to progress with 3D concrete printing, and that set us in a good space. But we wanted to do a bit more. And that's where Manchester Metropolitan University came along and said, look, have you thought about how you could expand a little bit into the 3D plastics printing area as well? So that formed another part of our project. And then Ian, who's on the call with us today at Scottish Water, saw our proposal and said, well, actually, this really does align to what we need to do in Scotland and aligns to our targets for net zero within the Scottish Government. So we could come along and help you on your way as well. So we formed a really, really good, tight partnership within the project and within this immediate project over the last few years. And what we've been focusing on is how can we use the concrete printing. And that was a great sigh from Stuart. Did you hear about that? But how can we use the concrete printing and the plastics printing to enhance what we do within the water industry? So we're not looking at how we replace our traditional disciplines of within civil engineering and the like. We're looking at how we can add to them, add skills to them, enhance what we do. We all know across the water industry we have a massive challenge, an exciting challenge moving into AMP8. There's a lot more work to be done within our infrastructure, and we're looking at ways where we can add potential and other means of doing things. And this is absolutely an example of doing this. And that is why Ofwat liked our bid. They were very much in the space of looking at different ways of doing things, achieving those challenges, those exciting challenges going forward. But there's also a bit around climate change and how we can reduce our carbon footprint. And we've been successful, and Natalie will talk about that in a little bit more detail in a little while, about how we're managing to use 3D printing to actually reduce our carbon footprint, and passing that on to our colleagues across the water industry to say this really is something that you can pick up and use. What we did within our project was those two things. So work package 1 was about the 3D concrete printing, which you're going to see a lot more detail about. Okay, we went to it was Wigan Wastewater Treatment Works, and some of you will have come along to see Natalie and the team. It was back end of May and early June last year, where we had our printing hub set up, and we were able to print for circular CSOs, rectangular CSO sections there. We produced a little kind of decorative piece for Sellafield while we were there, didn't we, Natalie? We looked at IED walls, so industrial emissions directive walls that we've actually moved to Ellesmere Port now and are actually physically in place at Ellesmere Port. We printed manhole rings as well. So we had a very, very successful couple of weeks with a printer, with a robot actually on site, physically printing items for both for use by United Utilities and for Scottish Water. We then transported that robot down to our Weaverham Wastewater Treatment Works, where we were able to print an actual distribution chamber in situ there, and that's all been completed. And it's just we completed that. We did have a leak on it, didn't we, Natalie? Which I'm sure you'll mention, and we reprinted again. And I'm happy to say the second time around there is no leak. It's passed its hydrostatic test, and we're just in the process of piping up to the distribution chamber at Weaverham. But that was really helped us to understand what we needed to do with regards to ownership of a robot. What were the pitfalls that we could face? Could we really go from printing at Wigan on Friday afternoon, packing up, and then printing again at Weaverham on the Monday morning? So that's the kind of, we wanted to understand the pain that goes with ownership of robots, and all of that information is available to those of us across the water industry. Just a little bit on work package 2 before we move on to Natalie and get into the detail of the concrete printing. So we've had lots of success in work package 2 with regards to plastics printing, using the resources that are available to us through the Print City Directorate at Manchester Metropolitan University. Over there in Manchester, they have a whole range of different plastics printers. They've got a metals printer as well. They've even got their own concrete printer, haven't they, Natalie? But they've got a whole range of different things, and we've been able to use that to look at how we support our operational colleagues and our colleagues within laboratories as well, to print things that maybe are no longer available to us from suppliers. So helping to really kind of stretch out the product life, if you like, of certain items of equipment on our sites. We've also been able to do some bespoke design work. So what you're seeing in the middle of the slide there is actually a bespoke instrumentation holder for our Better Rivers team for river water monitoring. We're going to use, I think, around 2,000 of those items in United Utilities on our CSO monitoring. So we're very much able to scan and look at items that are already available or no longer available for older bits of kit on the open market, and then we're also able to do bespoke designs and have them printed. The key bit to the plastic printing is once you've got that data signature, that design in CAD, you're able to do mass printing, so you're able to do it over and over and over again. Okay, and once you've got that library, if you like, of designs, then it's really a good thing for us to start picking up within the water industry, and we've certainly been doing that within our operations team within United Utilities. Just let Simon back in. Before we move on to Natalie, just what the expectation is for the next hour or so. We've got a lot of information off the back of our project. We've presented in lots of places. We've been off to conferences. We've done lots of online stuff. You may have seen a showcase that we all did a few months ago now. Oh, yeah, it's okay, Simon. Just keep trying. We'll keep letting you in until it works for you. We've done a lot of work. We've done a lot of dissemination work, which some of you may have seen in the past. We're going to give you a bit of an overview by Natalie of the concrete element, that work package 1 element there. And then we're very interested in receiving your feedback and your thoughts on concrete printing and what can be done. And that's really the key to this surgery session. We've identified yourselves as key people that could help us. Okay, that's why there's only a select few of you on this call. This is not one of those mass kind of online presentation things. We've done them in the past. What we're after is your help, your support. We want to pull on your brains, essentially. Okay, so we're hoping that by having your individuals such as yourselves on the call, we've got kind of the big brain of 3D concrete printing here, and we're able to draw on your knowledge and experience to understand where else we could go as an industry with the robot and with ChangeMaker3D. So that's it from me. I think I've covered everything off. If I haven't, Natalie will correct me on something, no doubt, somewhere along the line. But Natalie, I think it's time for you to take control of the slides.
Okay. Brilliant. I think that's worked, has it?
I think so. I think it's asked me if I want to take back control, which I definitely don't. So there we go.
Right, can everybody see that? You see that okay?
We certainly can.
Good. Thanks, Richard, and Ellis for just sort of setting the scene and giving a good background. And as we've said just now, I'm Natalie, and I'm the CEO and co-founder of ChangeMaker3D. We've worked with Richard and the team for 3 or 4 years in water, but as a startup, we've been around since 2017, really looking at where we can deliver lasting impact with the 3D concrete printing, whether that's in a more sustainable way for infrastructure, or maybe as we progress forward, looking at affordable housing for people in the UK as well. So for now, our focus is on really getting a clear view of the products, the print process that adds value to the water industry, but also bringing some of our cross-sector learnings that we've had the opportunity to have with High Speed 2, with Transport for Wales, and with more recently Sellafield, and really helping that cross-sector learning to shape some of what we've done in this project, but also to de-risk across the board. And I think that's really, really important. There's so many areas that we've needed to get into in this project that are about de-risking both the material, the product, the print process, and picking the products that we have given us a really good opportunity to do that, to benefit AMP8. So just a bit of an overview of Printfrastructure itself. It's something that came out of some project development that we were doing 3 or 4 years ago. And it really came as a result of, well, we need to give this technology and this construction method a name, something that people could connect with. And it was a little bit of a joke name to start with. We sort of battered around the kitchen table, and then it stuck, and people really liked it. So we became a trademark, and we were able to then say, well, what does it really mean? And for us, as a company, it means that we get to be an integrator. So we get to work with all of the 3D printing materials available, all of the robots available on the market, and we get to look at what the customers need and where the pain points are. We then develop the design of the products, as you'll see on this presentation, and then we reverse that back out to say, well, is it this material or is it this robot? Is it on site or off site? And we make the technology fit the solution, not the other way around. So that's been something that we've been evolving over the last few years. We do have some material providers like Cybe Construction who were involved in this project, who we've got to know their material really well. We've done a lot of testing with it, but that isn't to say that as we evolve, there may be other materials that are better suited or different robots that we need to bring into to deliver a certain type of solution. And what I'm going to do now is I'm going to show you a video which I'm hoping is going to have sound, but it's a couple of minutes. It's Ofwat when they came to visit the site, just to, kind of giving feedback on what they're observing and the benefits that they were starting to see could be driven through into the industry. But let me just try and play it first. Can you hear that?
Yeah, hello, my name is Mark Hannis. I work for Ofwat and I lead on the Ofwat Innovation Fund. So we are funding through the Innovation Fund 90% of the costs of this project. So we're pretty heavily involved, although it's not particularly hands-on, and we're really excited to see where this goes. Yeah, so it is the first time I've seen this up close. I wasn't quite sure what to expect. It's certainly bigger than I thought it was going to be, and also just how quickly it's churning out the things that it's actually building through the concrete as well. I was amazed in the 10 or 15 minutes we stood watching it, how much it grew during that short period. So I think they're the two things that I was really excited and interested to see. We're looking for alternatives to mass capital building products and projects, and I think the UK manufacturing sector at the moment probably cannot cope with the sort of demand the water sector, at least, not to mention all the other sectors, are about to put upon it. So if we can find alternative ways of that manufacturing, I think that's going to really, really help. In terms of timelines, I also think it's going to have some cost and efficiency benefits as well. And I think what the challenge, I guess, for the water sector is to see what's going on here, and for this to get some traction a little bit further afield than just United Utilities and its partners. And then we can really test whether or not this has got legs and is viable in the long term for the water sector.
I'm Kieran Brocklebank. I'm the Head of Innovation here at United Utilities. One of the beauties of 3D printing is the speed. We can print things faster than we can placing purchase orders, waiting for a factory to build them and to get them delivered. The fact that we're not going to be reliant on other suppliers, we're going to be self-sufficient, we'll have our own designs, we can print them ourselves, and of course the fact that we can make bespoke designs very quickly means we can print bespoke products faster than we've ever been able to do. I think we should all get excited about that. All those years of hard work, of working with our partners, with ChangeMaker3D, our United Utilities engineering community, we've converted an idea into a practical reality.
That's not good. It's frozen for me. Oh, you've started again.
Yeah, it's frozen. Kieran was just about to say they've turned an idea into a practical reality, and that's something that we should all get very excited about. But and that was just about the end of the video. But hopefully that gives, it explains to you in a couple of minutes how the Printfrastructure Hub operates. You can see the robot in there. We put an awful lot of planning as a team collective into not just selecting the products, but then having a production flow as well. So really understanding like that entire work area, from the pre-printing where we had the base labs through to the printing in the hub. Then we had a post-printing area. We had waste away. We really did have a micro print site wrapped around the print hub, and understanding, you know, how we placed things in the hub made a difference to whether we could print 3 or 5 products in an 8-hour shift. So there was an awful lot of productivity innovation happening, not just, well, can we use the hub to print a product in a day? It was, we pushed it much more than that. And actually, you can see on the following slide that in that 2-week window in Wigan, the tent had been, all the enabling works had been set up prior to that with Costain and the supply chain, North West Water. And then we deployed the robot in on the Monday, and we were able to go through the 5 products, which we've got further on. We had base slab variations as well. So we didn't just look at, you know, what we were printing, but how we could interface with the base slabs, how we could optimize design there. We achieved 23 products printed across the 2 weeks. Yeah, and you know, there were over 30 hours of print, more than 30 hours of printing, and thousands of layers going on across those 2 weeks. And it didn't all run smoothly. You know, we had the power that went down one day. We had the forklift that decided it was going to have an issue another day. We had high winds overnight. So we did get, you know, a lot of the sort of construction challenges happening around us. And not only was that great learning for us, but also we were able to see how quickly we could get back up online, you know, when the power's gone down, or when we take the robot off the lorry. It's about an hour and a half between fixing the robot in and tracking it into position and then calibrating it off the lorry. So we were able to prove the theory as well. And you've seen some of these pictures maybe before with Richard as well, and this just shows you the 2. So we had the 2 weeks in Wigan, and then, as Richard was saying earlier, we pushed the boundaries and said, well, what happens if we print without a tent, which we've never done. Don't think anybody in the UK's done that before. So, you know, taking on the British weather, all right, it was May, June, but, you know, we still are not guaranteed good weather. So we said, well, let's see what happens. One, without the tent and any weather protection, and 2, what happens if we print a distribution chamber in situ? So we print it exactly where it's needed. So again, those 2 things for us really did push the whole learning on the whole team on. We were successful with getting the robot to site. I mean, that was like Richard said, we kind of packed up one weekend, and over the week on the Friday, and then on the Monday we were in Weaverham. We've had to change some of the base design detail for the second print. We tried to print directly onto the concrete slab without sort of an RC base and getting a good join on it. And we think that that's maybe where some of the leakage was just coming through. So we've now, we did sort of a version 2, put a base slab in, and I've got some video to show you. And as Richard said, it's now water retaining. But again, we wanted to see, well, how far can you take that in situ printing? And some of you may or may not be familiar with the technology itself. We've used the SciBee robot, which is an ABB robotic arm, essentially. But in terms of sort of a design or a production process, you're thinking about it in 2 ways. One, it can be tracked very agile around site, which you've seen. It can be used off-site if need be. But we've seen most benefits going onto site and being able to print and respond in real time. And from a design point of view, you think about it in 2 ways: either an entire structure, which is say like the distribution chamber you saw there, or the CSO chambers. They're within sort of a 3 meter by 3 meter diameter, where the robot can print as one structure. If you need to go larger than that, which we needed to with Scottish Water, and they gave us a really good challenge on a larger rectangular CSO, we then broke that down into modular parts. So the robot was able to print them, but we then had to think about all the join detail, the interface, how they were going to be installed. And again, you know, there were some good bits, some bits that we wanted to learn from, things we probably would do differently again on that. But it's proven that the robot can design and print in those two ways, which was a key thing we wanted to evidence. We've also had a lot of scrutiny over the material science, which, you know, you'd expect. We had this in our HS2 project as well, and we were fortunate enough to have the funding to do a lot of testing with the BRE group. So looking at a lot of product testing and just really testing to destruction, seeing what happens if you with fire resistance, all those sorts of things, which had definitely fed into this project and how we were going to design with the material. And also, just prior to this, UU did some sort of chemical testing with us as well, where we put some elements of the mortar into sort of sewage treatment works and left them there for 6 months and then tested them. So you know, that this is something that we know, particularly if we start to move into clean water, which would be the, you know, a direction we'd want to go in, because we've only been in wastewater to now. Obviously, there's going to be a lot more to do around the material. And these are the design standards that our structural team have worked to. We've had in the project both the Scottish Water and the UU chief structural engineers overseeing the design and the sort of the principles that we've been working to, and making sure that they do tie back into being compliant. So before we even got to print on site, there was a huge design program, certainly the biggest design program we've done as a team, and it took a lot of collaboration to understand exactly what we needed to do with the material to get the best product output. And just before I move on, I like that photo because it shows you 3 of the 5 products quite nicely, and we can just talk around some of those in a bit more detail. But the one on the left is a manhole ring, and we were given a standard manhole diameter by Costain. And whilst we didn't innovate at all with this, other than to prove you could print it in about 1 hour and 15, something like that, what it did show is that as we move into AMP8, if there are bottlenecks in supply chain, like traditional supply, like precast, essentially, if we end up with delays, then you could, as a water company, just have a call off of 3D printed manhole rings, and it would keep the programme on track. So 2 of those manhole rings have now gone up to Scottish Water. They're going to be used in the programme there. And actually, we took quite a lot out of that. We didn't anticipate we were going to get such a like a positive use case for it, and it does have carbon reduction benefits. It does have speed efficiency with it as well. And then the circular sewage overflow chamber here, again, we printed this as one entire structure. So from the base slab, we then went all the way around up through the circular element, and we also, in one printing, were able to do these columns, which act as lifting detail, but also support the reduction of being able to sort of come up out of the ground when these are placed in the ground. And the inlet and outlet pipes are also reinforced through this detail here as well. And then with the IED walls, I've got a couple of slides on these, but these are part of the Environment Agency's directive to have some of the higher risk areas on wastewater treatment works reinforced around the boundaries of the site. And some of you may well be looking at these yourselves. Now, when we came to these, I'll just show you now, there wasn't really a like a precedent for them. The sort of the UU team with some of the design team were kind of looking at legato blocks and, you know, having so high and so deep. And so we were given an opportunity to really I think this is probably one of the most innovative approaches we've been able to have within the project, because we've been able to look at the curved arched wall. We've been able to play to the strengths of the printing. You saw this being printed in the video. This takes less than 2 hours to print. And we've also been able to look at some bespoke shapes on the base slab, which allow us to get angles in the placement as well on site. The 3 columns provide reinforcement, but they also provide lifting detail. And as you can see on the slide there, we were given the permanent design brief. So knowing that, excuse me, knowing that in the event of a catastrophic failure, they're fairly sizable forces that are coming, particularly onto the base part of the wall, and they have to be able to have containment for 8 days. So we weren't given, there was sort of no leeway in the fact that, oh, it's a 3D printed product. It was, if we're going to do it, it has to be compliant. And I'm really, absolutely thrilled. A couple of weeks ago, we went up to Ellesmere Port, and 6 of these walls, I think it's 18 meters, have now been installed. And these are actually live on the programme. And, yes, early indications are that they look like a good solution. And that's fantastic, because we've been able to do something genuinely adding value into quite a challenging area for the water companies to have to try and address quickly. We also had Jacobs was sort of running in parallel with us on all of this, pulling information out as we went around carbon, the commercialization. So what is the cost benefit? Is there real financial commercial value in doing this as well? And also just looking at the social impact that we were having as a project, which was really important to us as a project team, that we recorded that. It was independent, and I'm really pleased that we had that, because Jacobs, they brought expertise to it that we didn't have as a team, particularly around carbon. We really did have some good debate about, where do you draw the comparisons with traditional? How do we, if we can't compare apples and apples, what are we comparing, and how can we be transparent about it? And what's the supply chain data available? And it was really robust. So, and again, with the commercialization, looking at, what are the economies of scale we'd need to have with some of these products to be able to benefit AMP8. You can see on the slide there that there is a cost reduction, which is always an aim with anything where we need to be able to introduce the industry. The carbon reduction is significant, so just over 50%. But for us on this one, it was the time reduction of up to 87%, which is massive. And a lot of that was gathered in the speed in which we can print the walls and deploy them to site, but also how quickly on site they can be installed, compared to that sort of more traditional legato block, very, very sort of labour intensive. You've got to wait so long for the concrete to go off. That's where we started to make those real installation benefits. And I think they look quite nice as well. I think they're, if you're going to have them around the edge of a lot of sewage works, they do look nice. So the combined sewage overflow, this was front and centre. This was quite, we put this on the table quite early on from UU, because there's such a focus on these in AMP8, but also looking at the standardisation around CSOs. So is there something that could be designed, like optimised in design, but also something that you could just have this design library of, well, we need a 10 metre cube, sewage overflow, or a 25 metre, and we just can, pull them off in a standardised way. We were able to, throughout this process, we'd started a patent application, and we were able to get that approved as we went through. And some of the design in this is actually drawing on the patent, which we were really pleased about. It has benefits. It is sort of marginally cheaper, but where it's sort of, pound for pound if you were going to buy it from precast, but where you get your real savings in this are, again, in the time and in the carbon reduction. So this comes as one structure, as you saw on some of the pictures. You're able to just drop it into the ground and then connect the pipe detail, rather than having to put several component parts together in a more traditional way. And if there's a particular site constraint, we've got the flexibility with the robot to maybe print these in situ as we did with the distribution chamber. So there's a great deal of flexibility there as well. So I think really, you know, we covered a lot of ground in the project. We were able to understand from Scottish Water's perspective some of their you know, programme requirements and where we have to be really focused on carbon reduction, but also learning a lot from UU about where we need to be targeting this into adding value into the challenges around you know, the scale up of AMP8 across the water industry. And I think being able to get onto site and have a live print hub, go across and then do something, you know, completely in the open, you know, like at Weavrum without any kind of weatherproofing, has been really, it's been really invaluable, really, for not just for us as a company and the partnership, but for the whole water industry to now have this as evidence. We do have a video of the printing at winter time, but Ellis, I'm not sure if it's on these slides. If not, is it worth just popping it into the chat? It's only 10 seconds. Perhaps we can have a look at it as we go through.
Yeah, I thought it was on the slide. It must just not be playing. Let me just quickly double check. Apologies about that.
No, that's all right. It's okay. We can share it. I'm just making sure I hadn't missed anything. Richard, have I missed out anything? Richard, you know, is there anything that I've not covered that you think was important to?
It's fine. I was just thinking, just on the ID wall side of things on the slide you had there. Obviously, that photo is not the installed, the finished installed photo. That was them just laid out.
Yeah,
to
sorry,
one side, ready to be moved into place. So you can see. Yeah. So the actual base, the base slab that you're seeing underneath each section there
will be covered.
Is underground. Okay,
yeah.
So it's I don't know whether I can just bring a quick photo up or not, whether we're allowed to.
Yeah, you're right. That's
but yeah, it's
that isn't the finished. it's laid out. No.
So if I don't want to take control, do I? But
you can do. Just share your screen.
Can I do that? And upset,
yeah, go for it.
Upset Alice's flow.
No, it's all right. Yeah, feel free. I can't find that video. Sorry. So yeah, if you've got something to share, that would be really useful. Now I can send the videos round in the summary after this.
Yeah.
So hopefully that's come through to everyone. That's just a picture of the wall when it's the wall sections when they've been installed. Okay, so
have you put it in the chat?
Oh no, I've tried to share my screen. Is that not sharing?
If I stop sharing, oh no, I don't want to do that. You have to take control, otherwise it'll end it all for everybody.
No, I don't. Okay, let's not do that then. I can put something in the chat for you, and then people can just open it up. Okay.
Yeah. So just moving to sort of next steps before we get into the group discussion. The whole project team, both in polymers and in concrete, we've been very focused on moving into business as usual. And not having that, not having all of this lost in innovation and then not transferring over. So we've been doing things like making sure we work with the contractors on the framework. So we as a company are now set up in the process of getting set up with Costain on the UU framework, which means, you know, there's a route to procurement, which is important for them. It's important for us. It's important for the outputs of this project. We want to work with designers to make sure that they're aware of these products, that they can be specified in the programme, that they can sort of reassure and encourage contractors that are taking on the install that, you know, there is a robust set of data around them. And the biggest next step is to just keep expanding awareness across the water sector. You know, everybody will have a perspective on it. Everybody will have something to add or to feed in. But this now does really rely on the industry sort of stepping into the opportunity and utilising the technology, whether it's with us or anybody else in the future. You know, for me, it's about the impact and unlocking the impact of this tech so that we can, we can see these products and others that will come along from this really utilised. Thank you. Sorry about my croaky voice, keep dying in and out as well.
Just wanted to say thanks so much, Natalie and Richard. That was really, really insightful. So we're now going to head over to the Miro board. I've popped a link to it in the chat, so hopefully you can all access it. But if you have any problems, just let me know in the chat. I'm just going to stop sharing the presentation and head over to the Miro board, and then I'll reshare that on my screen.
Alice, I'm not seeing anything in the chat, unfortunately. So if you want to...
Oh, I've got it.
Yeah. Oh, is it come through? I did pop it in the chat. Yeah, someone's thumbs up.
Yeah.
All right. I can't. Well, it hasn't come through to me. You try again.
I'll pop it in the chat again. Give me 1 second.
There might be a problem with my move. Oh, right, here it is. That's good.
Have you got it?
You've nudged it through. Brilliant.
Oh, it's reloading.
We want to take a few questions, I suppose, any clarifications and so on from anybody on the call.
Yeah.
That's okay. Nobody's got any questions. That's all right. With that. Oh, Simon, how are you?
Hello. Yeah, very well. Thank you very much. And it's excellent to hear about the work that's going on. So thank you for that. I suppose I was keen to know if you're putting any sort of sensors in or anything like that to monitor sort of long-term behaviour of installed 3D printed assets, or is that a future possibility?
I mean, from our point of view, it's something we've looked at, not just in water, but with rail as well, with the toilet pod, for example, to see how, if there's any moisture, from a building regs point of view. The short answer is we haven't done it to date, because I think we've been focused on sort of getting the basics right and getting the basics approved. Are loads of cracks going to suddenly turn up overnight with the material? Is it going to perform visually how we want it to? We've looked at, we've talked about sort of doing, sort of laser testing as well, and just gauging what's happening on the inside, as well as sort of the sensors. So I think it's an area that does add value. I think we just need to be clear on what it is we need to monitor, and why. And what and if that's the best way do we monitor it in a real life setting, or do we perhaps do some lab tests of freeze thaw, durability, that kind of thing? So I think as we move into clean water, I think there's definitely going to need to be more robust testing around this, definitely, and as other materials are introduced as well. Yeah,
it'd be interesting to see some sort of accelerated aging testing or something like that, I suppose, and just see how it. But yeah, no, thank you.
It's a great question, Simon. What we know very, very early on, in fact, it might have been before our project when we were in the innovation lab, we did mention putting some kind of sensors within the printing, but I'm not sure exactly where that went. I think it just it wasn't kind of, as Nasty says, it wasn't kind of a burning issue at that time, if you like. And but I can understand where the question's coming from now, and it's certainly maybe one of the next steps. What we did do is obviously we took a lot of sample blocks, so that have been off for analysis. So everything that's been printed had a block taken before and after the print. In fact, I think you might have, I know you missed the Wigan bit, didn't you? But yeah, it was a case of we have done those. They've been off for analysis laboratory, so that's all good. So we've been crush tested and all that great stuff. So we understand that element. We also stuck one of them in the weir of the primary settlement tank at Weaverham as well, and left it there for 6 months just to make sure we didn't get loads of microbial growth and so on all over it. And happy to say that didn't occur, so that was all good from that point of view as well. But something that was mentioned, but unfortunately for one reason or another we didn't pick it up in this phase of development. Certainly something to look at.
got to pick your battles, haven't you? No, that's absolutely fair enough. But it's just I had a conversation with a chap called Professor Colin Smith from Sheffield University last week, who's very interested in this area of research. I think it's a new area. I mean, it's not like it's routine to actively monitor civil engineering assets, and it seems like there's heightened interest in it. So maybe there's some collaboration there that we could set up.
No, sounds brilliant, Simon. If you've got contact details, can that probably best is probably you, Natalie.
Pop them over. It'd be good.
Great. Yeah. Thank you.
Thank you.
I can see that Chris has got his hand up as well for a question.
Yeah, thanks, Ellis. Firstly, great presentation, Richard and Natalie. It was really interesting, and I love the video as well. Apologies if you covered this. I was just curious as to why did the project sort of pick CSO chambers, the rings, and the IED walls as the applications? Why those ones in particular?
It's what came out of discussion, Chris,
right.
within UU and Scottish Water with different capital delivery teams and so on. That's where we went towards. So it was just a case of, obviously we've got quite a large, and I'll speak for UU, we've got quite a large CSO program, okay, our Better Rivers program, where there's quite a heavy pull on existing precast systems and so on, as you can imagine. So it was a good opportunity there to just see if this could support the delivery of that program, okay, and help us out there. So that's where the CSO side of things came from, and then the IED walls, that was from a discussion with the wider UU team, and it was just highlighted around, I think, the business as usual or standard design at the moment is legato blocks, and it was the same discussion around, well, that sounds brilliant, but if we can't make enough of them in the timescales that we need them, then how else can we do things? What's a different way to doing it? And as a team, we said, well, we could have a go at that if we can get close to the structural requirements that we need. Then let's go. And that's where the curved design came from. It was the guys at Constructure, wasn't it, Natalie? So rather than using lots of rebar, should we look at using the curve for its kind of compression strength, if you like, when it's faced into the flow? So it was that's where they came from. Chris.
Thank
you.
I
got that right for you, Natalie.
Yeah, no, nothing to add to that. I think it was just, as Richard said, really, it just came out of discussion with things that are on people's minds for AMP8, things that may have high demand or have, have lack of availability for doing things quickly enough.
Right, that's great. Thank you.
Yeah.
Thanks, everyone. Would it be all right if we moved on to the...
That Simon Kerr's got his hand up again.
Oh,
he's coming back.
He's coming back for more. And who can blame him? Absolutely.
Happy if Ellis needs to move on. I can always ask the question another time. But I don't want to hold you up.
No, go on.
Just ask away.
It was just I'm thinking, the 3D printed concrete is an isotropic sort of material in nature, in that it's not uniform in all directions, and whereas I suppose a cube sample might be compacted and made so that it is completely uniform. And I wonder if you've done any testing of the actual 3D printed material in different directions to see, does it perform as a sort of a homogeneous sort of monolithic structure, or does it have different behaviors in different axes?
Yes, we have. A lot of the work we did with the BRE was on the 3D printed walls themselves. We also did a pull test with one of the distribution chambers in this project, and we designed it for, I think it was like 7 newtons, and it went up to 30 newtons, which was the highest amount on the pull test machine, and it was still fine. So we've definitely got practical data on the material itself. We've also done, we've taken we've printed a beam, if you like, and we've sliced that down into sort of what would be similar cube sizes to like a standard concrete test. And we've tested some of those as well. So not just having the material poured into, you know, like a standard concrete cube box, the steel boxes. So we've done quite a lot around that. Yeah,
Brilliant.
both in this
Oh,
project and in previous.
fantastic. Oh, thank you.
Yeah.
No, that's a question that we often get asked. So that's
Yeah.
great to know. Thank you.
That's fine. Right, so Gabrielle has just put a hand up, okay, which is fine.
I promise not a question. It's not a question at all. I'll disappear. I'm actually about to drop off. Just saying hi to Natalie.
Hello, you're
Great
right. Long time no
presentation.
see.
Long time no see. Now United Living, but I've got
Okay.
Lewis Watts and Ian as well from United Living on the
Brilliant.
line. So they will
Brilliant.
feed back into your session and support the workshop part of activities. So look forward to potentially collaborating again, Natalie.
Yeah,
thank you all for the
likewise.
presentation.
That's all right. Good to see you. Speak to you soon.
Thanks
Cheers,
for
all.
joining.
Thank you.
Yeah.
Thank you. Bye.
Right, Alice, I've just noticed that you've got 5 questions in this Miro board.
Yeah. Sorry,
I
yeah.
thought it was only going to be 3. So
That's
we're
okay.
going to have to crack on, aren't we? Okay.
Yeah, that's all right. So if everyone has managed to make it onto the Mario board, onto question 1, if we can all see that. How can an on-site 3D concrete printing hub support your AMP8 delivery challenges? So yeah, feel free to take a post-it note and just add your ideas to the board. Also feel free to discuss anything sort of via camera and mic if you want to as well.
I need some help just making sure I know how to take a post-it, I think. What do? We just grab one and
You should just be able to
feed.
click and drag it, yeah.
Click and drag it. Got you. Thank you. Great.
I've got to try and get back in because I managed to chuck myself out of it. Right, great.
Oh, cool.
Um,
So I think there's lots of like really nice ideas there. Thank you everyone for adding to it. I'll leave the board open after this session as well if you did want to sort of carry on adding ideas and stuff. But yeah, I'm going to move us on to question 2 now, just to make sure we can fit them all in. So question number 2, do you see a route forwards for 3D printing within clean water as well as wastewater? If so, what do we need to get there? So yeah, similar process to the last one, just take a post-it note and add your ideas. And if anyone's got any questions or wants to sort of ask the presenters anything, then I'm sure that'll be fine to discuss. Cool. I think that's. I can't see anyone else typing unless I'm mistaken. So yeah, thanks again for all of your ideas on this one. And if at any point anyone wants to like speak about any of these points, yeah, please feel free to get involved. With that, I might move us on to the next question if everyone's happy with that. Just sort of make sure we keep the 11:30 finish.
Yep.
So we now on to question 3. So, where do you think your capital program could most benefit from the 3D concrete printing technology? Yeah, looks like that
some
one's.
people have moved on to question 4 already on your
Oh,
list.
have they? Eager. Thanks a lot. All right, I'll follow them there now. See you at question 4. Okay, so question 4. How would you approach the adoption of the technology within the AMP8 framework?
Yes, it's good. There's loads. I'm loving reading all these. Really good. Insurers have come up a few times on this and one of the previous slides. So that was something that we've also spent quite a bit of time having to work through up until the HS2 project. Just after that, we were able to get some PI cover. Prior to that, the insurance market was really tricky with us. But we have now set a precedent, not just for us, but if any other 3D printing companies need PI, it can be done, and also product liability insurance. So we've taken quite a lot of that forward, so that we don't have as many barriers around insurance and liabilities, particularly when we get into sort of the more commercial realm. So I think it's absolutely right that you've put that on there.
Yeah, Natalie, that's a big challenge for us. I don't know if I don't imagine it's unique to Anglian Water, but it certainly is a big challenge for us. So could I just check then, so under your professional indemnity insurance, do you take design responsibility then for the things? Yeah,
there's a design responsibility element in there. We can't, a lot of the standard contracts look for 10 million PI, which we haven't explored going up to it at this point. One, because it would cost us far more than we can afford at the moment. We'd need to have a proper pipeline confirmed to be able to step into those numbers. But sort of 2-3 million of PI is not unreasonable for us to be able to achieve.
That significantly reduces the barriers to entry, doesn't it? Yeah,
that's why we why we absolutely hammered the insurers. We were like, we can't not have this, and we even got sort of HS2 to some of the earlier meetings, and when they were looking at how to, when it was their project back in 21, we did an awful lot of engagement with the insurers who I just think they needed reassurances, that we were they need to understand the technology. I mean, I can't speak for other print companies or any other insurers, but I know through our own journey we've taken that very much front and center.
I think that quite naturally concludes that section. So going to move on to the last question of this part, and then there'll be like a little bit of time at the end just for generic Q&A. So moving on to question 5. Having seen what's been developed within the Water Industry Printfrastructure project, what are your main concerns regarding the use of 3D concrete printing? And to be honest, I wonder if insurance might have popped up in this one, but we've probably just clarified that. So
I'm just reading the one about availability of equipment. It's an important part of the overall scale up. You're absolutely right. And that's one of the reasons why, from our point of view, we want to be whole of market, because it can spread some of the risk around having access to robots as well. We are going to have some of our own robots in-house. We haven't purchased any up to this point, but it does make sense for us to now have some in-house print capability ourselves, as well as being able to reach into the supply chain. But there's there's definitely a need for the 3D print suppliers to have some visibility of this as well, so that they can get investment and they can commit. We're building out an entire supply chain. They certainly, some of our European supply partners would be able to commit to scaling up, but again, they'd need evidence of it, which is understandable. But it's a good problem to have if we get to that point. It's a great problem to have. and that's where some of the OEMs like ABB Robotics, we've met with them in the UK. It would be bringing everybody together. It wouldn't just be the 3D print robotics companies. It would be right back to how can big giants like ABB help unlock it and accelerate it as well, and how do we regionalize it? So we've definitely, in the project team, we've got some thoughts about having, regional print hubs. I think once somebody else put on one of the post-its about having like a centralized hub and a call off. So that's definitely something we've recognised and talked about, whether that's per water company or whether that's as a pooled resource for the water companies in different regions. There's loads of different ways you could, whether it's in-house in the water companies or out in the supply chain. There's lots of different ways you could approach it. Yeah. So a few people have put skills on here. So skills is actually that we have got a work package in this in the WIP program where we're going to be looking at providing some information for both the polymers and the concrete printing. We're going to be doing sort of like a toolbox talks for the first, just as a general awareness raising, but also then setting out some of the sort of job descriptions or the skill sets required for print operatives, digital print leads, all those sorts of roles that are going to be coming in, and also looking at sort of maybe sort of like a module, like an outline framework. We have been talking with some of the contractors like BAM and VGC as well about supporting with maybe more of a national skills framework. And we've been talking to CITB about that, but at the moment CITB aren't in a position to commit to it, but certainly we've got industry support. And we can build on what we started to shape in this project as well. Yeah. I think the limitations, someone's put flag in the limitations. I think that is important. And one of the things we sort of, when you're going through initially through that product scoping stage, we do end up ruling quite a lot of things out that actually are just better in either a precast or, you're just not going to get the value out of it through doing it in a 3D printed way. So you do have to be realistic about where this does add value. Of which there's loads of areas. We don't need to try and badge it as a one size fits all solution. It's not that. And I think as well, one of the things we've been able to do in this project is really lean on the 3D printed material. So you can look at it in a couple of ways. You can either sort of use the printed material as a formwork and then have more like the sort of standard in concrete infill. And that's absolutely fine if that's the way that the product needs, if that's the way that it's been designed. But through this project, we've also been able to really say, well, what happens if we lead with the 3D printed material and then only reinforce it where it's needed? And I think that hopefully will go a long way to building the confidence in the technology and the product as well, rather than seeing it as a something that can't fully be utilized within design.
Just from my perspective on that, Natalie, how have you gone about doing that? Is it things like making sure things are curved to add sort of like structure and rigidity to them, or?
Yeah, I mean, we love curves. If we can get a curve into a design, we will. But it's exactly that. It's starting with the properties of the material, and then designing with those. And our design partners, Constructure, they've been with us for many, many years, and they've built up that knowledge. We've asked some of the more experts in the designers with Cybe as well. We've asked them to sense check some of our thinking, like they've helped us push boundaries a bit as well. But you ultimately you think in terms of the material rather than think in terms of it being a formwork.
Okay, that's really interesting.
Yeah.
Thank you for that.
Someone's popped site safety on there. It's really, really important. It is within this project, we had a couple of visits from some of the health and safety teams from UU to observe the safety protocols, to observe and give some feedback on what they were seeing. We obviously went through a whole RAMS process pre-start. This was really, really front and center of how we operate, and also how we support some of our like European supply chain partners to come on board with the safety in the UK as well, and the principles that we have. So we have things like exclusion zones around the printer. Only qualified people go near the robot. They have somebody essentially like a banksman watching. If they do have to step in or interface within that exclusion zone, there's a second person, and there's also 3 safety emergency stop buttons or remote buttons for the robot that always somebody has access to. One of them's behind the robot, one of them's on a remote control, and one of them is at the front of the robot. So we've actually been involved with developing the ISO standard, the international standard, and we joined a global committee of I think it's about 60 representatives. And I hadn't appreciated how important the safety view of the UK was going to be in that discussion, but we brought a lot of safety principles into that ISO standard for the quality management, which I was pleased that we were able to do for on behalf of everybody that goes out and operates. So yeah, safety I can't stress highly enough, and I know Richard and the team, it's been top priority for them as well, and in Scottish Water.
Yeah, it was a fantastic bit of learning, I think, for yourself, wasn't it?
Yeah.
So that interaction at site, particularly at Wigan, when we had the hub there, and all the feedback that you got. Okay, yeah. It was all meant. It wasn't meant to be negative in any way. It was all meant to help you develop as a team and make sure that you align to the requirements of the water industry, not just United Utilities. So I think it was well worth doing. And it's worth doing for ourselves. You mentioned our health and safety. Business partners visited the site, didn't they, to see what was going on, and it was really key just to, not for them to come along and say, oh, you can't do it like that and you can't do it like this. It was to help them understand what it was we were doing, so that they could kind of create mitigations and so on within the approach. So and help us understand how to deal with that kind of robot operative kind of interaction there, that interface.
Yeah, and I know when we were on the HS2 programme, the products there, the retaining walls, they underwent a Cat 3 check, like an independent design check, and we actually evolved the design of the wall to remove, to minimise the interface with the human and the robot. And that was driven by that third-party view from the designers as well. They really challenged us on how to design in some of the safety processes. So yeah, a lot of learning around that.
I've just thought of one. I don't know, I haven't put it up on there, but I don't think it's worthy of the board. Obviously our friends Daz, Baz and Gaz, the local graffiti artists, when we're talking about these walls,
Yeah.
Has anybody put any paint on these walls and seen whether we can actually get it off there?
No, we haven't, but we talked about that a lot with the toilet pod, where we were designing that with Amy and TFW. Graffiti was a huge area of discussion, and I think if we were going to do any testing, we would probably get like sort of a patch of the toilet pod and spray it and see what happens to it. So yeah, we did get because obviously the nature of rural train stations and stuff, graffiti is a key risk for them. So yeah, we haven't done it yet, but we could easily do that. I'm sure the team would love to be graffiti in the toilet pod.
Rich will be there with his spray can, yeah.
He will, yeah.
Yeah, I think that probably concludes that section quite nicely. So I'm going to stop sharing the Mario board. But yeah, as I say, I'll leave it open. So if anything pops into your mind later on, please feel free to revisit it. From that, just has anyone got any sort of like general questions that they wanted to ask like near the end of the session now? No.
If I may ask another question.
Oh yeah, go for it.
Yeah, of course, sorry, get in there.
Yeah, just to break with tradition. Yeah, I mean, I just wonder, what your timeline is for sort of sharing outputs from the project, and what sort of things are possible to share. You mentioned there's some patents and things like that, which obviously I guess there's a limit to what can be shared, but yeah, I wondered if you could give us an idea of what we could expect.
Yeah, that's fine. So what you'll find, Simon, we've got our what we call our landing page on our website. It's via the UU website, our innovation. So what we'll do is we'll share the link to that page in due course. But you'll find that we've got technical reports for work package 1 and work package 2. There'll also be some skills and knowledge kind of sharing. We're looking with Ian at the supply chain school and seeing how we could use that to actually share out the kind of the upskilling information from the back of this as well across the water industry. As you know, it's Ofwat-funded, 90% Ofwat-funded, so we do have to share what is produced within the project, so what the outcomes are. There will be some technical data available to you, just from the testing that we've done from the concrete within the project. Okay, that's a key thing. The background remains with Natalie, I suppose, and with Manchester Metropolitan University, but the foreground information we do have to share because of that funding route. So the plan is to make all that available via the website link, which we'll let out to all of you and to everybody within the water industry. Timescales for that, we're just in the process of writing. Okay, so we're writing all of our stuff up. So it's probably around June time is when the drafts will be ready, probably closer kind of July, August time, when we've got the Ofwat approved final deliverables going out in the way of documentation. Simon.
Brilliant.
I just wanted to add to that as well. It probably will also end up on the Spring platform, I hope, because there's already a water industry Printfrastructure section on there. So yeah, any other like reports and stuff that we're allowed to upload alongside it.
Fine. Yeah, fair enough, Alice. Good.
Yeah.
Why have we got the UU one then, Alice? What was the point in doing that?
Oh, I don't know. I think it was like to live on UU's own website. That's it's more of like a background website for the project, but then we've got like the option to upload resources to it.
Okay, we'll have a chat about this offline, I think.
No.
Okay.
We will be sort of putting out more information on the installs as well. So I know that Scottish Water, we've got Ian with us. I know there's some comms and video content and stuff that's being created, and the same with UU. So we will be between sort of now and June, hopefully being able to sort of share on social media some of the, you know, you've seen sort of the work in progress of the IED walls, but when that's all finished, that'll come out. The same with some of the products that have gone up to Scottish Water as well. Yeah.
That'd be great. Yeah, thank you.
Okay, I think I'm sort of happy to leave it there. But yeah, I just wanted to say a massive thank you, especially to Natalie and Richard for presenting, but also really appreciate everyone coming along and adding some great ideas to the Miro board. The results from this, I'll sort of publish the recording and process the Miro board into like a more presentable document. Should be on the Spring platform within around a week's time. I'll also upload the slides from the presentations. And yeah, as I said earlier, I'll respond to the meeting invite for this when they're live with the link to them so everyone can see that. But yeah, thanks everyone. Hope you have a good rest of your day.
Thank you.
Brilliant. Perfect, Alice. Thank you ever so much. Take care all.
Okay, thanks all.
Thank you.
Thank you.